Hello everyone and welcome to a new Anyverse platform tutorial. Today we're going to take a closer look to one of the most unique features of the Anyverse platform, that is the sensor simulation. This feature basically allows you to generate one single render with all its hyperspectral information that is generated by our unique render technology, which is hyperspectral, basically uh, generating information of the energy on different wavelengths that is bouncing around in the scene that you're rendering. And thanks to that hyperspectral information, we can very faithfully simulate any sensor. And with the sensor simulation feature, what you can do is use that hyperspectral information and different sensor configurations to make decisions like what are the limits of your sensors? Um, what sensor is better to use for different use cases of my perception system? What happens if I change the white balance in my ISP? Or if I decide to have different weights to translate from one color map to the next, and what are the results on the final color image? What is the best approach in the combination of sensors and ISPs for whatever problem I want to solve with my perception system? All these questions can be answered by using the sensor simulation feature. So to start using it, I have already opened the workspace associated with the tutorial, which is basically the AV ADAS workspace, where we have a scene. This is the layout. Let me close this because I don't need it. And this is what my camera is seeing from the global view. Let's go to the point of view of the camera. And this is the field of view that we're getting because this camera, which is rigged in an ego, has this lens configuration. It's got a default ISP configuration and a sensor. All this are part of the workspace. I have them all here. I can see that the lens has this focal length that gives me this field of view. The default ISP, it's a very basic ISP with just gamma correction, so we get good contrast and brightness color image. And we're simulating the Sony IMX 265. For the first sensor simulation sample that I'm going to be running, I'm going to be using a different sensor. Now, how can I get new sensors? Well, you just need to, you can just create a new sensor here, create camera sensor, and punch in all the parameters that we need to simulate the sensor. Where can you get those parameters? Well, we use different sources for that, the spec sheets of the sensors, and obviously the web. In particular, there is one very interesting website from this company, Lucid, that creates cameras putting together different ISP sensors and lenses. And here you can find very good specifications of the sensors that they use. For example, in this case, the Sony IMX 273. So here you have all the specs from the pixel size, for example, which is something that we need, the resolution, of course, but you can get much more detailed information with some sources of noise, saturation capacity, which is our well capacity, the number of electrons that make every pixel cell saturate, and many more. And the most important ones are these graphs here. This is the monochrome quantum efficiency curve, and these are the RGB quantum efficiency curve. These are critical for a good and physically correct sensor simulation. So you need all this information. Okay, so and this is a good source to get them, right? So you can see that for the Sony IMX 265, we already have all this information. But as I say, I'm going to use a different sensor. Out of the box, if you will, in Anyverse, in the Anyverse platform, if you open the resources view and go to the templates, you can see that we have some predefined sensor templates here that you can freely use. Let's use the onsemi Python 1300. So if I'll double click on it in the resources window, it's added to my workspace. Let's close here, and you can see that this is very different sensor than the IMX265. The quantum efficiency curves are very different. You can see that the gain it's smaller for all the colors. Obviously, it has a different pixel size, different levels of noise, etc., etc. We're going to be using this one for our first sensor sample. So the first thing I have to do is go to my camera and substitute the Sony by the onsemi. Here we go. So there it is. And now I'm ready to run my first sensor sample. To run sensor samples, you have to have what we call a sensor sample container created. So you select here the sensor samples, and you can see that I already have a container that is called sensor benchmark. But if you don't, and you probably want, when you open the workspace from scratch, you just can create a new one. Just click here, and it asks you for a name, and you can create it. For the time being, I'm going to use the one I have. So the next thing is just to launch this sensor benchmark. Oh, wait a second. I have to show you something before that. The generator has a section for the sensor sample configuration. It's important that you have the camera that you want to use for the sensor sample selected here. In our case, in this workspace, we only have one camera, so we have this one by default, and that's why we don't have any errors here. But if the camera that you're going to be using is not visible or doesn't have a sensor configured in it, it will give you some warnings here and will tell you what to do. So you have to make sure that the camera is selected and that you have the render quality that you want for that sensor sample. I recommend that you use always ultra because it's probably the final quality you're going to want. So you want to compare to with your final output's going to be. So yeah, just leave it as the default. So now we're ready. Now we can just go and say, let's run this. And yeah, I already punched in this name here, which is a sensor sample for the onsemi Python 1300. I just picked this name, but you can pick whatever name you want. I mean, it's good practice to identify your sensor samples by the sensor that you're using. But yeah, you can decide otherwise. And here we go. We run it. So just open the executor and generates a scene based on what's in the workspace and just sends it to the cloud to render. If I have this open in datasets check set here and close this takes me to the Anyverse Studio dataset explorer, and you can see that there is a section for the sensor samples, which is different to the datasets that you generate at a scale with thousands of samples. And this is just one single sample that is running. You can see the progress. This is being run in the cloud, as you very well know. And we just have to wait for it to finish, and then we can play around with the sensor sample. But we don't have time to wait in the tutorial, so I have run sensor sample before with the Sony IMX265. When I click on it, you can see the color image that is generated by the render and by the sensor simulation with the configuration of the sensor that you had in the workspace. But not only the sensor, but the ISP as well. Okay? So what we do when we click one of these sensors is that we download all the hyperspectral info on which we generated this color image, the raw image and the color image, and have it stored locally. And now we can run the sensor simulation locally and get immediate results with the change of parameters that we do. So let's start, for example, changing a little bit the ISP. So if I go here and take a look at the quantum efficiency curves, I can see that the levels for the blue are lower than the level of the green, and the red it's a little lower than the green as well. And as you can see, the color in this image, it's a bit greenish. A way to fix this is through the ISP would be to say, okay, let's make the blue to be a little bit more important than the green and the red, but we saw that the red it's a little bit under the green, so I'm balancing all the colors here. So let's do 1.1. Here we have two buttons, the denoise and the apply. The apply will apply all the changes that you made in the parameters, will apply them. If you don't have the auto denoise on, it will generate an image very fast, but with some noise coming from the statistical render. If you have the auto denoise or you click the denoise button after the apply button, you will get a clean image. I'm going to be setting this to auto, so we always have the denoise on. So now I apply this, and this is updating the image. It's basically getting the hyperspectral image and apply all this configuration to it to generate a raw image and a final color image applying the ISP. And you can see that we have balanced that. Now, my image here is not that greenish. Okay, you can see that we've balanced that. And that the final image, it's a little better to look, a little bit more balanced, right? So that's something that you can do. Other things that you can do, play around with the gamma correction for brightness and contrast. So typically for a computer screen, gamma correction, it's between 1.8 and 2.2. Let's see what happens if we do a 1.8. It's recalculating, denoising, and there you go. Little bit less contrast, right? So you can see that we kept the balance of the colors. You can see it here in the white. Okay, this white is whiter because the balance of the colors is good. We can even try something else and increase this a little bit more. And try to get a wider color there. Maybe we went a little bit too far. So now it's a little blue, but I mean, the overall image is there, right? Okay, so we've played around with the ISP. Now let's see what else we can do. Let me go back to the original image to have it on the right hand side as well. So we reset everything. And there's a better way to reset. It's just I'll show you in a bit. Okay, so we are with the original numbers, but yeah, it's a better way. Just go out and come back in, and you have the original numbers, right? So what are the things we can do? We know that sensors have noise, and that noise, obviously manufacturers try to reduce it as much as possible, but in given stream conditions, that noise shows up. What are those typical extreme conditions? Very low light. So very low light make the noise appear in the images. And that will depend on how much noise the sensor has, and when it starts appearing, it will give you like the most extreme conditions of low light that your sensor can handle. How can we simulate that with the sensor simulation feature? So we need very low light. Since this render was run with an exposure of 2 milliseconds, and we get this. I mean, it's a bright day out there, so 2 milliseconds, and the sensitivity of the sensor that is controlled with the analog gain. You can think of the analog gain like the ISO of the film. If we think about the old analog cameras, with this analog gain, which is the normal analog gain, could be similar to 100 ISO, and this exposure time, we get a good picture, well illuminated. We cannot retake the picture because that means another render, reducing the light. But what we can do is say, okay, let's reduce the amount of light that reaches the sensor. And for that, we get higher exposure times. And let's do this 10 times less exposure time. And let's play around with the ISO. So let's reduce this to 0.03. So we have less gain, and with configurations like this, where you reduce the amount of light and the gain is still too much. Okay, it's because we have it a little saturated. We start seeing the noise, but it's too saturated. I wanted to reduce the light 100 times, not only 10. But when we reduce it 100 times, you can see, and we have, and we reduce and increase the sensitivity of the sensor. We are reproducing like very low light conditions. And you can see that in this very low light condition, you can see the noise. You can see it very clearly that we're getting noise. So playing with the exposure here, we can get to the point where we find what's the limit of light that I'm not getting noise in it. And that helps me understand the limits of my sensor. And I can decide if it's good enough for what I need for my perception system or not, or I need to try a different sensor, right? So that's another of the use cases of using the sensor simulation feature. But what else can we do? We can compare different sensors, completely different sensors. So let's try to compare the Sony IMX265 with the onsemi Python 1300. Okay, this render hasn't finished yet, still working on it, but I can reset the results here, and I have the configuration parameters of the onsemi Python 1300 here, and I can just punch them in. It would be something like the pixel size is, instead of 345, is 4.8. The color filter rate will be the same. The noise, the DSNU is 0.5. The PRNU is 2. The red noise is 945. We have soft noise as well. We're going to keep the exposure time. Now the analog gain for this one is 1041. The well capacity in this case is 10,000. Dark current is 5. And the voltage swing is the same. We still have low pass filter. And hey, now the quantum efficiency curves. Now I need to load the Python quantum, quantum efficiency curves. Here it is. And we have no filter and we're ready to go. There you go. Very different. Very different. Complete different sensor, complete different output. You can see that for this sensor, the balance of the colors is more to the red. Actually, you can see that because of the quantum efficiency curves. It's more efficient on the reds than on the others. But again, you can do the same. Let's crank up a little bit the blue. Let's crank up the blue and a little bit the green, 0.2, something like that. And after recalculating, there you go. Much wider here, right? It's much better. But again, you may want the default configuration of the ISP because it's got all the benefits for your perception system. It's completely up to you. But using the sensor simulation feature, you can basically play around as much as you want and get to the values that you need, and see what is the best sensor for your final perception system. So with this, I think I've covered a couple interesting use cases that you can use yourself. Remember that this tutorial it's available once you start your Anyverse Studio in the homepage, and just click on the workspace to open it and start playing with your sensor simulation. I hope you enjoyed it. I hope you learned, and stay tuned for other Anyverse platform tutorials. Thank you very much.